Okay, can everybody hear me this morning? Okay, great. Well, good morning. Thank you for coming to the conference. My name is Chris Milligan. I'll be kicking things off this morning. So, until recently, I was the Factory 4.0 coordinator and digital acceleration senior manager for Nissan's powertrain operations in Decker, Tennessee. Lots of things have changed as a result of COVID. For me, one of the things that just recently changed is I'm now a part of an incredible team with Boozell and Hamilton. We provide AI-based solutions for supply chain and asset reliability. So very exciting new world for me. So many of us are here today because we see a revolution coming. The business world and the technologies that power it are evolving faster than at any point in history. We don't have to wait for some breakthrough to make full automation possible, as most of those technologies already exist today. Which is why it vexed me so much when I didn't have a good answer to a question my vice president asked me. Why can Amazon completely change their logistics system over to a highly automated one so fast, and yet we can't? By chance, I had just started a course on corporate entrepreneurship and innovation as part of a MBA program at UTC. With the help of my professor, Dr. Stephen Olson, I was able to finally answer my vice president, and that answer is what we're going to talk about today. With a new engine line being planned at the time, we had the perfect opportunity to test our ideas in what we branded the Nissan Intelligent Factory. We proceeded to design a line that was big data ready, fully IoT enabled, and AI powered so that it could be highly automated effectively. Our goal when it launches later this year is to be the first in our organization to be certified a digital lighthouse factory by the World Economic Forum. Before we get to the technologies, let's develop a clear understanding of what the problem which we intend to solve. First, is there even a problem to be solved to begin with? One way we can measure the rate of automation is to look at the purchase of industrial robots by country. From this perspective, the United States certainly seems to be lagging the other automotive powerhouse countries, especially when you compensate for the size of their respective economies. You may be wondering about China down near the bottom, now that they are boldly entering the automotive market. Well, here's what 2018 looked like in terms of robot purchases. As you can see, China's looking to catch up very quickly. Maybe that hasn't convinced you. Well, here's the Federal Reserve's index of production per employee. We can think of it as a measure of production efficiency. It has been largely stalled since we came out of the great financial crisis. This is meaningful because the manufacturing efficiency has been in the center of American economic growth for decades. That efficiency was an unstoppable force that incessantly continued despite of market shocks, trade agreements, or recessions, right? It's been going on since the Great Depression ended. Though this may be a positive and significant reason for the record-breaking levels of employment leading up into the COVID crisis, it's not economically sustainable in the long term. Before we try to answer the why, let's first be sure we all agree that automation is a good thing. Because one of the potential reasons is that we are simply anxious over the impact of these advancements on good-paying jobs. A few years back, there was a number of articles suggesting that there would be a jobless crisis as a result of all the automation advancements. And it's true that manufacturing jobs are likely to go the way of farming, which was once a dominant part of the economies of the world. Today is only a small fraction of the labor force, while simultaneously lowering the number of food insecure people in the world. This anxiety has gone all the way back to the birth of the Industrial Revolution with the Luddite attacks on the looms that gave birth to it. In our own history, the legend of John Henry, who lost his life competing with the steam drill while digging through the mountains of West Virginia. The reality is that savings from innovation is always reinvested, leading to some surprising results. For example, it was thought that the personal computer and spreadsheet would decimate jobs for clerks and bookkeepers. What we didn't forecast was the growth in management analysts, financial managers, accountants, and auditors that were born out of having easily available data for analysis. Another example is the automated teller machine that actually resulted in more tellers because it lowered the cost of opening bank branches. Yet there is one thing we should be concerned about. If you look at the number of Amazon employees per year from 2015 to 2017, it went up as they rapidly automated. But it was at the expense of their competitors who were left behind. With so much competition now entering the automotive business, history is primed to repeat itself. One aspect of automation, artificial intelligence, is expected to create the greatest economic boom in decades, adding up to $26 trillion to the world's economy by 2030. And hence why I believe full automation will be normal by the end of the decade. This single technology is expected to double the rate of economic growth over baseline between now and 2035. Just from one technology alone, when we have many that have come out in recent years. That is why I made the leap to working on AI 100% of my time. Rather than crisis, I expect it to be an economic supercharger. So if automation is good, and the price of robots keep falling, and the price of labor keeps rising, why didn't the economic crisis lead to more automation, rather than this sort of stagnation? Well, one of the most important lessons I learned in business school is that the thing holding American companies back is what MBAs like me learn in business school. At least that is the explanation of one of the most brilliant business researchers of our time, the late Dr. Clayton Christensen of Harvard. Now, I won't be able to do Dr. Christensen's justice in one slide, so I just highly recommend you watch his talks on YouTube. Dr. Christensen understood that the problem getting in the way of businesses investing in disruptive innovation is because business managers are doing what makes the most sense in the moment. Financial management courses in business schools have been teaching business managers to compare companies via ratios, things like internal rate of return and return on net assets. And it certainly seemed sensible to me at the time I was going through those courses myself. How else can you make apples to apples comparisons between companies? The problem is that it leads to capital only being invested for quick turnaround, which is by its very nature means that risky breakthrough and disruptive innovations don't get funded. He also points out that CFOs learn to treat capital as a scarce resource, which made no sense in the years following the financial crisis because interest rates were at historically record lows. However, I believe the fear of being shut out of capital markets explains the current situation, where we are flush with capital but unwilling to spend it. This, I believe, is the primary cause of the automation stagnation we are currently experiencing. This situation has been aggravated by the rise of the activist investor. The fear of having one of the efficiency-minded experts at shareholders meetings does about as much damage as having them active within your organization. Contrast that with the venture capital where internal rate of return and return on net asset is horrible, yet VC funding is booming now, getting money from major investment firms. It is because startups don't have to play by these rules that's leading them to have an advantage over incumbents. This is one of the reasons why the average lifespan of a company on the S&P 500 is falling and expected to continue falling through this decade. To drill into this idea a little deeper, I'd like to introduce a business model developed by the University of Michigan called the Competing Values Framework. It starts with two axes of priorities. The vertical axis differentiates an emphasis on flexibility, discretion, and dynamism from an emphasis on stability, order, and control. The horizontal axis differentiates an internal orientation with a focus on integration, collaboration, and unity from an external orientation with a focus on differentiation, competition, and rivalry. What comes from this is four quadrants. The bottom right quadrant is the compete quadrant that focuses on competitiveness and market performance in the short term. The upper left quadrant is its competing value, which collaborate, which focuses on long-term developments like employee relationships, teamwork, and community. The bottom right is called the control quadrant. It is very important for quality control. It emphasizes doing things right and careful incrementalism. Its competing value comes from the create quadrant, where breakthrough innovations and creativity are the priority, which by their very nature is risky. As markets mature, competition in price and quality leads to the lower quadrants becoming stronger and getting most of the attention as the upper quadrants become less of a focus. This is a natural consequence of being in a mature industry and does no real harm until the market takes a left turn. Then it's not so good, because that is when it takes a creative team to find new approaches in a changing market. The automotive industry is now facing a tsunami of left turns, with more changes to our business model in the next few years than the entire history of the business. On top of that, connectivity and AI may completely alter the driving experience to one of passive entertainment. New forms of transportation are even beginning to look like more than a futuristic pipe dream. On top of all this, demands on our capital funds, we are supposed to somehow manage to invest in new supply chain and manufacturing methods. And if the organization makes it through all that, the payoff is not likely to be as good as it was historically. The uncertainty of this future makes it very difficult to invest for the long term. Now, some of the senior leaders here today may be thinking that is not the answer, as they try desperately to get their teams to come up with innovations to implement some of these new technologies available to us. So why is it such a struggle to get our operational teams to identify investment opportunities? In short, manufacturing hell. You might have heard this term a couple years back when one automaker tried to boldly automate several historically manual processes. Now, if you'll bear with me, I'd like to share an analogy that helps us think about the cultural resistance to automation. Factories are by their very nature problem generators. And it's the job of our employees to try to continuously stay ahead of the problems, though most of the time they feel like they're underwater and the problems are coming faster than they can identify, solve, and eliminate. So when a new type of automation is brought into the picture, those employees only see it from the perspective of new problems it will create for them, and new things usually come with lots of problems to be solved. So it's unsurprising that there is a difference in how management sees these as new opportunities, where employees see them as something to dread. On top of that, people are often distrustful of new technologies in the first place. Otherwise, shows like Black Mirror wouldn't have the fan base that they do. We automatically imagine all the things that could go wrong with them. So we have two challenges to overcome if we are to see full automation become a reality. One, financial, the other, cultural. And maybe we can find ways to not only create the performance gains we are looking for, but also allow us to balance our employees' needs and maybe accelerate our creative spirit. To see how we can achieve this, I want to use artificial intelligence and machine learning as an example. This certainly is seemingly a mysterious field of computer science that has many dubious expectations leveled against it. But if we leave the killer robots to the futurists for a moment and just concentrate on what is making impacts to business today, it's not so nefarious. Data, no matter what source it comes from, tends to exhibit patterns. Machine learning allows computers to adapt to those patterns to make predictions of some kind. That seems a little pie in the sky, right? So if you want to think about how we are progressively automating our vehicles, it starts small. Aids like cruise control, which have been there for years. Then attention aids like blind spot warning were added. And recently we've got things like emergency braking and 360 safety shield teaching our customers that the car has their back. Now we have low levels of automation such as adaptive cruise control, lane assist, and automatic parallel parking. Soon, higher levels of automation will be achieved through incremental advancements until finally we reach full autonomy. And maybe we can do the same kind of phased approach to make our factory teams more comfortable with AI as well. To provide an example, I want to use some technologies that can help us improve our product quality, such as AI-based visual inspection, digital quality gates, pattern detection, and warranty response. Today, we can track more information about our product than ever before. With RFID and visual codes connecting unique parts to measurements being taken during the process, each part can have its own digital fingerprint. With this, we can map out a future with breakthrough quality, starting with our current condition, automatic detection. This uses rule-based detection on problems, right? So either cameras to visual detection or those test equipment, they have some kind of limits to them. Because these systems are already familiar to our teams, converting them to like AI-based cameras can be an easy starting point because it's a bridge to something that they're already comfortable with. A little step up from that is change monitoring. This is a technique that identifies the normal pattern of behavior for a process, and when the data trends out of this pattern, it automatically alerts the parties concerned. Once a problem is identified, systems can be put in place to help engineers identify factors that lead to changes through correlating everything from upstream measurements to maintenance activities automatically. Measurement correlation then paves the way to measurement predictions. Machine learning algorithms are trained to know how those upstream factors will affect downstream processes, so as to make it easy to know what adjustments to the process have to be made, or what adjustments need to be made to adjust the final product. Once teams are comfortable with such prediction models, they can then be used to autonomously control machine parameters to keep processes operating nominally at all times. All these combined satisfy each quadrant of a competing values framework while providing world-class quality. This is just one example of how we can start thinking about automation, not as a new technology, but as to try to lower cost, but as a way of lowering the waterline for our teams. Another analogy I found useful to understand this framework is the flywheel. A flywheel in this context is an energy storage device. It was this flywheel diagram on the back of a napkin that started Amazon. Online retailers have the advantage over brick and mortar stores in the fact that they can serve the long tail of customer needs rather than just the most basics. This increase in selection leads to a better customer experience, which leads to more traffic, which brings in more sellers, making the tail even longer, increasing selection more, and on it goes. Jeff Bezos' idea was to spin up this flywheel, then siphon off some of its energy from it to lower his cost structure, such as those Kiva robots that they're so famous for in their distribution centers, which in turn allowed them to further lower their prices to increase their competitiveness. I was able to start my own flywheel within my organization by implementation of IoT, machine learning, and other forms of automation to accelerate improvement cycles so that our maintenance teams had time available to do other things than just troubleshoot and repair equipment. Once our flywheel was spun up, we started spending our time installing quality control automation in the form of that roadmap that I showed earlier. That in turn reduced costs from direct labor while increasing quality. By the time I left that team, it was practically guaranteed that if I walked into the maintenance office, the 3D printer was running, making some new prototype, and someone was on AutoCAD, had AutoCAD open, designing a new solution. So for me, AI and IoT have the biggest benefit as problem-solving solutions. The primary reason that troubleshooting is so difficult and time-consuming is that we don't have all the information readily available about the problem. These technologies change that. The only challenge is that it's hard to make direct correlations between their addition with some kind of financial return that immediately impacts budgets. So it's important that we pair these kinds of technologies as a counterbalance or complement to automation. I've seen what manufacturing hell looks like when lines are highly automated, and it's much easier to manage them once these tools are in place. In fact, that is why our newest line, my top priority was to make every single sensor on that line an IoT sensor. So the data from that for those sensors can be fed into a cloud-based AI system, because every failure requires something to change, and that change can be detected. As problems are reduced, the number of people are required to manage it in our plants also is lowered. So we can incrementally lower each until we reach some kind of sustaining level of a lights-out factory. So this is my answer to the problem of cultural adoption of automation. Now that we've thought about cultural issues, let's think about how to overcome the financial limitations holding us back. Before I do, I want you to think about the process that your teams would have to go through to identify and implement a new technology under normal incremental improvement cycles. New technology implementation tends to be a long, drawn-out process performed serially, which can take years in some cases. Why do we do this? Because many of us have been burned by an idea that sounded good, but in the long run, we would rather not have implemented, and in some cases, we consider it an outright failure. I've heard such stories in every plant I've been to for benchmarking. Many of them talk about automation graveyards behind their factories. So in the software world, they talk about the option to buy or make a solution. But if we think about how risky some of these technologies are, wouldn't it be better if we could just rent it and try it out? The as-a-service business model can work just as well for us. We pay our employees by the hour for things they do for us. Why can't we do the same for a robot or a piece of software? Then we don't have to deal with the whole CapEx process at all. It just needs to provide enough benefit to save budget required to pay for the service. This could work for anything that doesn't require setting up an expensive infrastructure to implement. Then if the product turns out to not solve our problem, at the end of the term, we can end the agreement. This also allows us to move quicker because everyone knows the risk is limited and we can rent solutions till we have a better handle on what we don't understand about that new technology. Then maybe we can accelerate that long process of implementing new technologies from one that is incremental to one that is exponential in nature and compounds. So if there's one thing I would ask you to take away from this discussion is that we should all be demanding things like robotics as a service solutions from our automation suppliers, because that's what's going to allow us to move quickly. One great place to implement this is around logistics. We've all got automated guided vehicles moving materials around our factories, but there are still numerous opportunities within plant logistics to automate today. The added advantage is that logistics companies like Amazon are investing in these same technologies, which means the technology will improve and prices will fall faster than if they were just being used to support manufacturing. These kinds of projects are not directly connected to the line, so they can be done in a way that lowers the risk of affecting performance. They also have a really good financial payback, which can provide seed money to pay for some of those other problem-reducing projects I spoke about earlier. Robots and cobots are able to do so much more today than we were able to just a few years ago, making them perfect for offline logistic activities like the ones I list here. And the current pace of new technologies within this space means that if you can't solve your problem with them today, just wait a little longer and the solution will come, because the opportunity is so large with so many logistics companies looking for the same kinds of solutions. Some of the more exciting things that are now possible because of AI in robots are robots that can feel and adjust as they are assembling component, which means that sensitive devices can now be assembled by a robot. With AI and stereoscopic vision, robots are able to see their environment and adapt to it with sub-millimeter level accuracy, meaning hard to pick. Those things that were once hard to pick up and place are jobs that are now easy and reliable, as well as adaptable. And human level dexterity is on its way with robot hands, much like our own. And researchers are hard at work in the lab designing AI systems that figure out how to assemble things without being explicitly programmed to do so, like these robots that are assembling these IKEA chairs. All this was done automatically. Robotic breakthroughs are cool for sure, but what I'm really excited about isn't your traditional robot. Imagine how many of us have researchers working with autonomous vehicles on our roads today. That is a very hard engineering challenge, but autonomous vehicles in factories are much more manageable, and new companies have risen to that challenge. You may be thinking these look a lot like the automated guided vehicles we are all familiar with. The difference is that these new classes of vehicles are powered by AI. So I've created this hypothetical factory to show what these new vehicles do differently. Loading and unloading of trailers is a notoriously difficult problem for traditional AGVs, but autonomous vehicles with AI-based object detection are overcoming these challenges. Large pallet delivery systems are possible now, and the advantage of these over traditional AGVs is that there is no tape, no reflector, and no expensive engineering costs to design paths and CAD drawings. Many of these can be trained by our own teams. The advantage of not being trapped in a loop or closed loop system is that work tasks never perfectly fit the number of vehicles, so there's usually some wasted expense. With vehicles free of infrastructure, that excess capacity can be shared with other tasks, allowing for economies of scale to be achieved. Backup vehicles can automatically take over if a vehicle goes down, and because these vehicles can route around roadblocks, they can actually drive around a downed vehicle, lowering our risk. The freedom these vehicles open up opportunities to do other types of deliveries that don't normally happen with traditional vehicles, like repair part delivery and small part delivery, even delivering materials from storerooms or taking away the trash. If you imagine the complexity that would create, it's important that the control software is heavily based on AI, not just in the vehicle, but also in the control software itself. The reason I focus on robots and autonomous mobile robots is flexibility. With so much uncertainty in our future, It's best to invest in things that can be repurposed, or if you're using robotics as a service model, whose contract can be ended if something changes in your contracts. Taken to its extreme with AI-based programming, we can imagine a fully automated future where robots can adapt to make several kinds of things in the ultimate flexible factory. Industry 3.0 assets depreciate with time and become more problematic with age. Such a highly flexible Industry 4.0 asset might appreciate in value over time because predictive technologies make them more reliable and less likely to produce bad products. This is especially true with modern machine learning techniques, whose performance improves as the amount of data increases. I'd like to finish with a brief statement about innovation. When I first started working on this speech, I had this plan to lay out opportunity registers and rich matrices, along with a guide on how to decide what to implement, because with so many advanced technologies to choose from, it seemed like we needed such things. And maybe you do. But instead, I want to share a story with you to finish things off. This is what a factory used to look like. Unsafe, crowded places. If you look carefully, you will see they all had one thing in common, and that's that belt drive system that powered everything back in the days of the steam engine. See, this system meant that everything and everyone had to work at the same pace, and a breakdown for one was a breakdown for all. So what do you imagine happened when the electric motor was invented? Not much. That steam turbine was simply replaced by an electric motor and nothing else changed for years. It took 30 years for a new generation of managers to figure out that if each of these sewing machines had its own motor, then workers could produce independently, which caused productivity to explode. But it took 30 years. So the take-home lesson from this is if some new tool needs to be implemented, or you have some idea of this new technology and you want to implement it, rather than asking how that tool fits your organization, I'd rather you ask a different question. Instead, think of the framework I've presented here today. Instead, you will have your innovation team simply talk to people, find out what their problems are, and have them describe those problems in detail. You can then identify tools that perfectly fit and solve that problem. I learned this lesson over again last year. I put 2 of my technicians from the automation team on an innovation project. I gave them complete free rein to solve a certain problem however they chose to. While the automation team was working on the new line, these 2 technicians on their own came up with an ingenious way to automate one of our most frustrating issues. When asked about the solution, the solution had already been designed into several of the new stations we were coming up with. They responded that they had performed those jobs as technicians and felt the manual solution was counterproductive. They didn't want to have the process on the advanced new line, so they did some Googling and found a company that could provide them with a solution. What I learned from that is that we just need to give our employees time to innovate and let them do their job, which is solve problems, because that's what we pay them for. Thank you. And I believe we have some time for some questions if anybody would like to ask. I'm not sure how to do that in the discussion, though.
Yeah, so we do have. Hi, Chris. Thank you very much for the presentation. So, just to shout out to the audience, we do have time. We have left enough time for questions. Just a reminder, there's a panel on your right hand side titled Q&A. So you can just pop in there and you can type any questions that you may have, and we can look through them now, and Chris will be able to answer them directly. Chris, are you sticking around on the platform for a short time afterwards?
Yeah, I'll be around for a little while.
Perfect. So there's also the messenger service as well. So if you've got any questions directly for Chris, you can do that as well. So we'll just hang on for a moment and see if any questions come flying through.
Okay.
On a side note, Chris, it's fantastic to hear the presentation. I know we've been speaking on and off for the best part of over a year now, and it's been really valuable, and you've shared a lot of insights, and it's all been really, really useful stuff for me. So I'd just like to show some appreciation from that side as well. And certainly the presentation didn't disappoint. It was very detailed. I saw towards the end, I don't know if you can see this, but there's a button at the bottom where you can press like. And I think when we got to the business problem section, I saw a lot of thumbs up around that sort of side. And it's certainly something that I come across quite a lot when I'm speaking to people as well.
Yeah, I think we all have things that we want to do, but getting the funding is just so difficult right now. And especially in this last year, became even more difficult, right? Because COVID has kind of put us all in crisis again.
Yeah, absolutely. So it looks like we don't have any questions. I think hopefully people will just drop you a message. No, we do have a question now. Okay, so Annie Zhang. So the question is, what are your thoughts on the international picture? With global supply chains, automation may be the most needed in countries least able to implement it.
Yeah. The interesting thing about that is, if you go to one of our low-cost countries, is what we call them in Nissan, the cost of the automation is so high compared to the cost of having people do things that it makes it difficult for them to implement them and get a payback. This is especially challenging with artificial intelligence. There are many people that within the economics world that are concerned that countries like the U.S. will actually start taking back manufacturing because AI is such a competitive advantage. So the good news is, we live in a world today where learning is so much easier than it was when I was young, right? So I'm on platforms like right now I'm working on another master's degree. I have students in that platform from around the world, and Georgia Tech has made it very inexpensive to get a degree in artificial intelligence. So there are ways to work around it, but yeah, it's a big challenge if you live somewhere that's already behind technologically to get caught up.
Perfect. Thank you. It doesn't look like we have any more questions. So once again, I'll encourage anyone message Chris directly, drop him a note. I'm sure he'd be happy to talk to you. But from my side, once again, appreciate the time that you've given for the presentation, sharing your insights, and especially for all the support that you've given us as an organisation in the lead up to the event as well. So thank you very much, and good luck with everything. And I hope we get to speak again in the future.
Thanks, Mark.
Take care. Thank you.